Could we survive on Mars without a spacesuit? Mars captivates us. As Earth's closest planetary neighbor, it represents a tantalizing mix of possibility and peril, offering the dream of exploration and eventual colonization. But have you ever wondered, what would happen if a person stepped onto the Martian surface without the protection of a spacesuit? Could a human survive in such an unforgiving environment? In this exploration, we'll uncover the realities of Mars and why survival without advanced technology is simply not an option. Earth is uniquely suited for life as we know it. Mars, though fascinating, is a hostile alternative, a harsh and barren world with none of the life-enabling qualities we often take for granted. One stark difference is the atmosphere. Mars's atmosphere is incredibly thin, only about 1% the pressure of Earth's. Even if it were a bit denser, it still wouldn't be breathable, as 95% of it is composed of carbon dioxide. Oxygen, the gas we depend on, barely exists there in measurable amounts. Without sufficient oxygen to sustain our lungs, a person would suffocate almost immediately. Pressure, too, plays a critical role. On Earth, atmospheric pressure keeps our bodily fluids stable and functional. Mars' low pressure would cause those fluids, tears, saliva, even blood, to vaporize due to a drop in the boiling point at reduced pressure. The Martian environment, therefore, isn't just inhospitable, it's actively hostile to human biology. Let's imagine an unprotected human stepping onto the Martian surface. The first and most catastrophic issue would be the lack of oxygen. Without breathable air, consciousness would fade within seconds, and death would follow shortly after. But suffocation isn't the only problem. In such a low-pressure environment, the liquids inside the body would swiftly begin to behave abnormally. Instead of remaining stable, they would start to boil at body temperature. This isn't a sign of heat, but a feature of physics, known as the boiling point drop, where bodily fluids would vaporize due to the near vacuum-like atmospheric conditions. This phenomenon is not theoretical. Similar effects have been observed in laboratory vacuum tests and high-altitude scenarios. On Mars, without proper pressure stabilization provided by a spacesuit, the human body would collapse under these extreme environmental forces. If the lack of pressure and oxygen weren't lethal enough, there's another major obstacle. Mars is cold. Incredibly cold. The average temperature on the Martian surface hovers around 80 degree, 60 degree. In certain areas and seasons, it gets even chillier, plunging below 200 degree, 130 degree. For an unprotected human, these frigid temperatures would instantly overwhelm the body's ability to self-regulate heat. Hypothermia would set in within moments, making survival impossible. Combined with the suffocation and pressure-related dangers, it's clear that even a brief exposure to the Martian environment would be fatal. Mars also has another hidden danger: radiation. Unlike Earth, which is protected by a magnetic field and a thick atmosphere, Mars is virtually defenseless against cosmic rays and harmful solar radiation. Every day, the red planet is bombarded by these high-energy particles. For humans, direct exposure would cause severe damage to tissue and DNA within minutes. Over time, such radiation would trigger significant long-term health effects, including a dramatically increased risk of cancer. But in the short term, even a single exposure would wreak havoc on an unprotected human body, adding to the ever-growing list of survival challenges Mars presents. While radiation, freezing temperatures, and atmospheric conditions dominate the discussion, Mars' weaker gravity also poses concerns. At roughly 38% of Earth's gravity, Mars would profoundly impact the human body long-term. On Earth, gravity supports basic bodily functions, like maintaining healthy blood circulation and muscle mass. Without sufficient gravity, muscles deteriorate, and the cardiovascular system struggles to efficiently circulate blood. Mars's weak gravitational pull would compound the difficulties of survival already presented by its extreme environment. Given Mars's lethal combination of low pressure, freezing temperatures, unbreathable air, intense radiation, and reduced gravity, surviving unaided on the surface is impossible. Advanced spacesuits, therefore, are indispensable for any meaningful human exploration of the red planet. Spacesuits aren't just fancy costumes, they are life support systems. A well-designed spacesuit acts as a barrier against atmospheric vacuum, stabilizes internal pressure, regulates body temperature, and provides oxygen essential for breathing. They also shield the wearer from harmful radiation, helping astronauts survive and work in environments far removed from Earth's comfort zone. For exploration on Mars, spacesuits will need to be even more advanced than those used on the Moon or the International Space Station. They must account for the extreme cold, the abrasive dust, and the long-term residence Mars exploration envisions. Each layer of these suits represents a technological leap designed to counteract the alien conditions awaiting explorers. The uninhabitable nature of Mars tells us something important about our own planet. Earth is extraordinarily fine-tuned to support life. From its oxygen-rich atmosphere to its perfectly balanced pressure and temperature ranges, Earth provides all that humans need to survive naturally. Mars, by contrast, shows how rare and fragile these conditions are in the universe. It underlines the vital role that a planet's atmosphere, magnetic field, and surface conditions play in defining the potential for life. The comparison with Mars forces us to appreciate the intricate balance that sustains life on Earth, something we often take for granted. The dangers of Mars also highlight the extraordinary planning, technology, and human ingenuity required for future colonization efforts. To make Mars livable, scientists and engineers are developing habitats capable of shielding humans from radiation, maintaining pressure, and generating oxygen. Such efforts will determine whether Mars can ever become a second home for humanity. However, exploration of this scale requires more than just science. It demands global collaboration and shared vision. Without international teamwork and significant investment in innovation, the dream of living on Mars will remain just that, a dream. Survival on Mars without a spacesuit is a swift and unequivocal impossibility. The red planet's extreme conditions serve as a stark reminder of just how dependent we are on our home planet's natural systems and the technology we create to venture beyond them. But in these challenges lies a deeper inspiration. Humanity has always thrived when faced with seemingly insurmountable odds. The pursuit of survival on Mars is not just a technical challenge. It's a testament to human resilience and creativity. So while stepping onto Mars unprotected amounts to a rapid death sentence, each challenge brings with it an opportunity to push the boundaries of what humans can achieve. Mars reminds us of Earth's delicate perfection, but it also propels us to keep reaching for the stars, driven by our desire to adapt, explore, and exist beyond all odds.